So solving differential equations, very often the only known information in an application involving two variables is how the rate of change in one of the variables with respect to the other variable relates to the other variable and or itself. Like wrap your head around that one. Some examples of differential equations are shown below. It's like sometimes we only know the derivative, right, or the rate of change. So dy by dx is 2 over x, dh by dt is negative 10t plus 16, and dt, capital T, by dt is 24 pi over 365 sine of 2 pi over 365t. So the first one represents the change in what with respect to what? Y, yeah, with respect to x. The second equation could represent the change in what could h height with respect to time. And the last one, big T. Yeah, I had to flip the page to find that out myself. It's temperature. Temperature. I guess we'll capitalize the temperature with respect to time. If the differential equation is known, then it is sometimes possible to determine the relationships between the variables themselves. For example, if dy by dx is 2 over x, then what's a possible relationship between y and x?
Y is inverse.
We could say, well, all right, so we know y prime is 2 over x, right? Well, that's really the same way. So what's y? 2. I heard somebody say it. Plus what? Plus c. Right? If dh by dt is negative 10t plus 16, then what's a possible relationship between h and t?
The absolute value bars
Around the x. Right. Thank you. So what's h?
Negative 5t squared plus 16t
Go on.
plus c.
Plus c. And if dt by dt, and what's t? Negative. Yeah. Negative cos.
365 cos of pi 2 pi over 365t.
All right. I will go with the cos of 2 pi over 365 t. But then that's going to come out, right? So what do we actually just need up front to get the 24?
12.
Yeah, we're going to get 24, right? So we're going to get a negative sign, blah, right? And then the 2 pi, so just negative 12. And
Plus c.
plus c. All right. So we have these relationships, right? So we know the rate of change. We can find the antiderivative too. So the solution to a differential equation in two variables is an algebraic equation that relates to two variables. That equation can then be used to answer specific questions concerning the variables. As you can probably see already, the solutions will involve antiderivatives. The characteristics of the differential equation will indicate a method that can be used to find the solution. So solving differential equations involving initial conditions, right? I mean, sometimes we know some stuff. So the differential equation, dh by dt, is negative 10t plus 15, represents the velocity of a stone thrown from the top of a building t seconds after release. If the stone is 60 meters above the ground 2 seconds after it was released, then determine when the stone will hit the ground. So we said, well, we found a possible equation for h, right? We said that h, or we can call it h of t, was negative 5t squared plus 15t plus c.
Isn't it 16? Oh, no.
Oh, yeah. Did it change all of a sudden?
It did.
Huh.
It went from 16 to 16.
Went from 16, yeah, I don't know why.
Why? It's all just
All right. So now it's okay. So now it's 15t. It makes the math easier. And what do we know then?
H of t is 60.
So h of 2 is 60, right? Which is negative 5t squared plus 15t plus c. So let's get rid of that h of 2, right? So we know that 60 is this. So we can find c. Oh, sorry. We know that 60 is this. All right, let's do this. H of 2 is equal to 60. 60 is equal to negative 5, 2 squared, plus 15 times 2 plus c. Okay, now we can solve this, right? So we just work it out. So 60, 2 squared is 4, negative 20 plus 30 plus c, 10 plus c. So c is 50. And that's, no, we want to determine when the stone hits the ground. So what do we know about when the stone hits the ground?
H is 0.
Yeah, so when the stone hits the ground, h of t is equal to 0, right? The height is 0. And we know that h of t is negative 5t squared plus 15t plus 50, right? So we use the initial condition to figure out what the c was. So that gives us negative 5t squared plus 15t plus 50 is 0. And then all we got to do is solve that, right? So what? Divide by negative 5. T squared minus 3t minus 10 is 0. Factor. Solve. Reject. And say what? Stone hits the ground. After 5 seconds. Okay. Good? Yeah. Go back up. So we're given the rate of change. We use the antiderivative to come up with an expression, a general expression. We then use some information that's given to get a specific, like the function for this particular thing, that we can solve problems. Differential equation, dt by dt is equal to 24 pi, blah, blah, blah. Okay, this one didn't change, right? So we can get our t. Okay, so what do we know? The temperature, so we're given the temperature on January 1st is -6. What's little t on January 1st?
1.
Not quite.
0.
0. Yeah, when I first looked at this, I was like, oh, that's a 1, and how am I supposed to do the cos of 2 pi over 365? But it's days after January 1st, so it'll be a 0. So we have -6 is equal to -12 cos 0 plus c. Okay, what's the cos of 0?
1.
1. So then, so what's c? 6, yeah, good. Because what I wrote on my incorrect sheet here. So this actually makes a lot more sense than the answer I came up with. So see, I was like a half. It's like for some reason I decided let's divide. So c is equal to 6. So our expression then is t is equal to negative 12 cos 2 pi over 365 little t plus 6. All right, halfway through the year, what's going to happen? What's this going to be?
0.
No.
Pi. Yeah, no, wait.
Okay, so it's the cos of, yeah,
Yeah, it would be. It would be 2 pi over. It's just pi. 64.
it'll just be pi, right?
Yeah.
Yeah,
How
so
dare you?
or halfway through the cycle of the cosine function, we have a value of.
It's 2 pi over 2. Damn.
Halfway through, we get what? Negative 1, right? Start at 0, or sorry, start at 1, drop to 0, halfway through we're at negative 1, come back to 0. So this is 18 degrees Celsius. Makes a heck of a lot more sense for halfway through the year than the 12 and a half that I had. So, wow, it's not that cold in at the end of June or early July. Okay. Yeah. Okay. Then we can state this, right? It doesn't hurt to write this, right? Like you could write the cars are getting closer to each other at, oh, which by the way we decided to give you, but it won't happen again. Okay. So just make a final statement for any of these things and then you're likely to get it right. Okay. So the temperature halfway through the year. Halfway through the year. Is 18 degrees C. And throw units in there too, right? Make sure there's units if that's applicable. Find the equation of the curve that passes through pi over 12 2 root 3 if the slope of the curve at any point. What?
Did you skip example 3?
Oh,
How is this fair?
it's not, so it's down here. Who knows? Okay, the slope of the tangent line to the graph f at any point x is defined by m is 2/3 x plus 13. Determine an equation. Okay, so that's a significant word in there, an equation. Okay, so what do we know, right? And we know that f prime of x is equal to 2/3 x plus 13. So what's f of x? Or, sorry, figure out f of x, write it down. We'll check and make sure, but you should do this on your own. Today we can answer. Oh, you have one too. What's the exam? Is it? Oh. Standard level or? Like it, one ace that. She, I got like a 5 in higher level. And all she does is radar hockey.
So was he smarter than your daughter?
Oh, yeah, probably.
How smart would you say your daughter is?
What's half of x? I don't need to get
Keep the
into trouble.
recording, but how smart is your daughter?
Very.
Okay, and how much do you love her?
A whole bunch. What's this? 1/3 x squared plus.
Z.
Okay, so what's an expression, an equation?
Any number.
Any number.
1/3 x squared plus 13 x plus 17.
7.
Yes.
Which?
There.
Put 69 and then say nice because that's a thing.
You will, where is it? Hang on. Okay, this was my original, what did I write in the original top of the page?
Ah, you wrote 7.
Yeah, I wrote plus 7.
Oh wait, so Yeah.
Now on this one I wrote like minus 12, but originally it doesn't matter, right? It's any number. Insert number here. Okay, find the equation of the curve. I just thought, yeah, okay. Find the equation of the curve that passes through pi over 12 to root 3 if the slope of the curve at any point is defined by secant squared 4x. So, what are we going to do? Okay, so figure this out. To pile this on the test, right? It'd be like 10 of these guys, and you're gonna have to, do general anti-derivatives, right? I mean, just make sure you're always adding c. You just have to think of the new government, and then think of an orange string, c plus, and then reverse that to make it plus c. Or just stick a plus c on the end.
I guess it makes sense because you're reversing the government and that idea works.
Quarter of what? 10
Of 4x.
of 4x
Let's see.
plus c. Okay, now what do we know?
That it passes through a point.
Pass through point, right? So what's the point?
That.
That could just be the generic what's the point question.
What's the point? There is no point. Well, it is that.
Okay, so we have a condition, right, which allows us to get the equation, right, because now it's going to be the equation. So what's the tan of whatever this is? Pi over 3? I believe it is root 3.
Root 3 over 4 plus.
So 2 root 3 is equal to root 3 over 4 plus c. So c is 2 root 3. Well, let's just write this as 8 root 3 over 4. Really? Minus okay, so what did it ask for on the equation of the curve? So the equation of the curve is so quarter can 4x plus 7 root 3 over 4. Okay. Yeah?
Don't we have to determine the slope of the curve?
It says find the equation of the curve that passes through blah if the slope. I don't think so. It just says get the equation. They gave us the slope.
Okay, yeah.
So they gave us the slope so that we could then do the antiderivative to get an equation, right, the plus c, into which we can substitute a known point, solve for c, and then get. So in this case, right, it's the or the equation. No, don't worry. Yeah, when you're doing, I mean, a lot of times that, did I answer the question? No, I'm like partway there, right, but I'm not there. The area under the curve of y equals sine x cos x from a to pi over 2 is 3/8. Determine a. Okay, so what do we know about area? Well, so let's say we got a function. If we do the antiderivative, we will use that to get the area, right, by substituting in.
It's the same thing.
No, you don't want to be using product rule, I don't think.
Oh, wait.
Oh, son of a.
How about this?
What's your fucking language?
Yeah, this is being recorded. So that's not the only one. You can do negative a half of cos squared x too, right? Cos x squared, yeah. That's sine squared x, but I'm just writing it as the sine of x all squared. So it becomes a half times 2 sine x times cos x, right? And if you want, you can do negative 1/2 cos x quantity squared. So there's more than one answer. Okay, but we have an area to work out, right? So we know the area is the absolute value of f of b minus f of a, right? So the area is 3/8. And f of b is 1/2 sine of pi over 2 squared minus 1/2 of the sine of a squared. So what's the sine of pi over 2? One, right? General. If I have to do any of the sine or cosine, I just sort of sketch it out, right? So there's pi over 2. So if I'm working on any of them, and that's quadrantal, right? It's 90 degrees with sine of 90, right? It's 1. So 1/2 minus 1/2 of sine a squared. Okay, so 3/8. This is 4/8, and we're going to be subtracting something from it, so we can drop the absolute value thing. And we can subtract 4/8 from both sides, right? So it can be negative 1/8 is negative 1/2 multiplied through by negative 2, right? So we clear off. So positive 1/4 is sine of a squared. So what's sine a? 1/2. Plus or minus a half, really, right? But so sine a. Let's pop up here. Now, seeing as we're looking for an error, we want our a to be below pi over 2, right? So we're just going to go with what? Let's go with pi over 6. Pi over 4 is root 2 over 2. Hey, a little bit. Go home, look at the unit circle. Write one down. You might want to actually write one down on, when you sit down to do the exam. You might want a unit circle. I mean, take 5 minutes at the beginning or sketch it out. And you don't really need this unit. You just need the first quadrant, right? I mean, after that, it's just reference angles and cast rule. All right, so we'll go with the a is pi over 6, right? It's below pi over 2, so it's the area between pi over 6 and pi over 2, be 3/8. Okay, because we also have, 5 pi over 6 and 7 pi over 6 and 11 pi over 6, but those are all bigger than pi over 2, so. A particle moves in a straight line. So this is acceleration, velocity, and displacement. Particle moves in a straight line and has an acceleration given by a of t is 6t plus 4 centimeters per second squared. Its initial velocity, v of 0, is 6 centimeters per second with a little box in front of the 6. No, the box isn't supposed to be there. Is it there on negative? Oh, negative. Okay, sorry, then it is a negative.
How dare you?
You're right.
Sir. Oh, sorry. I didn't even look. I just guessed.
Negative, yeah.
Math hero.
Well, at least it printed properly. So initial velocity v of 0 is negative 6 centimeters per second, and its initial displacement is 9 centimeters. Determine its position function s of t. So we can start off by saying, well, we know that a of t is equal to v prime of t, which is equal to 6t plus 4. So what's v of t? 3t squared. Yeah, so 3t squared, so it's the antiderivative, right? And we know that v of 0 is negative 6, right? So we can say v of 0 is negative 6, which means that negative 6 is 3 times 0 squared plus 4 times 0 plus c, or c is negative 6, which now gives us v of t. 3t squared plus 4t minus 6. Now we're supposed to figure out its position function. So we know that s prime of t is equal to v of t. So what's s of t?
Plus 2t squared minus 6t plus c. Oh.
I agree.
Oh!
No, that's good. Come on, everybody started working it out, and that was what was up there, and so we're all good. Now, what did they tell us? S of 0 is 9 centimeters, right? So we were given S of 0 is 9 centimeters, or just 9, I guess we don't put the units on. So 9 is equal to 0 cubed plus 2 times 0 squared minus 6 times 0 plus c, or c is equal to 9. So S of t is t cubed plus 2t squared minus 6t plus 9. Okay. And that's it, right? So the next one, the last one, so you to do the work for the last one, you just flip the page over, it's blank. Okay, and so I'll do it up here, but an object is thrown from the top of a 140-meter tall building with an initial velocity of 15 meters per second. If the acceleration due to gravity is approximately negative 10 meters per second squared, then determine an expression for the velocity after its release, the velocity 1 second after it's released, its maximum height, the velocity of the object when it's 50 meters above the ground, and the velocity of the object as it hits the ground. Okay. So what have we got? So they said that A, acceleration is negative 10, and the initial velocity, so v of 0 is 15. We pull the units off. And that it's a 140-meter tall building. So we've got S of 0 is 140. Okay, so this is what we've got to work with. All right, so what do we know? Well, yeah, so v prime of t is equal to a of t is equal to negative 10. So what's v of t? Negative 10t plus c. Now, we know v of 0, so we should just be able to go straight to v of t, right? So what's v of t?
Negative 10t plus 15.
Yeah, negative 10t plus 15.
Do we need to show the work on an exam of like v of 0 is equal to negative 10t plus c and then do all that crap?
Let's take a vote. Should we have to if it's just 0?
No.
No, okay. So I think it's fair. If you're given, now if we're given v of 2, then yeah, you got to substitute in and show it. But if it's v of 0, you know, I think we saw the futility of, well, we saw what happened when we did last time. Hey, here's all this, yeah, look, it's just this, so.
Okay.
I'm gonna make the call. Then I will check with the others and just, you know, I don't want to say, oh, I told them they didn't have to show that. And the velocity object 1 second after its release. So v of 1 is negative 10, 1 plus 15, which is 5. Is that it? Should I just stop there? Yeah, let's put in some units, right? We got 5 meters per second. So v of positive. So what does that tell you? It's still up, going up. Yeah, it's got a positive velocity, right? So it's still going up. C, the maximum height. When does that happen?
When velocity equals 0.
Yeah, so the max height occurs when v of t is equal to 0. Right? So as long as its velocity is positive, it's going up. If its velocity is negative, it's coming down. And if its velocity is 0, then it's neither going up nor down. But it's reached it. Excuse me, it's reached its max height. So we want negative 10t plus 15 to equal 0. So what's t? 1.5, right? 1.5 what? Seconds. Okay. So 1.5 for 3/2 seconds. Okay. I mean, I guess it all depends on what we're going to do with that. The velocity object when it is 50 meters above the ground.
It was asking for maximum height.
Oh, the max. Oh, right. So we're not even done. So then we need s. So s prime of t is equal to v of t, which was negative 10t plus 15. So what's s of t? I won't write anything down yet. Negative 5t squared.
Plus 15 plus 140.
So should we go directly there, or should we do the c and then?
Just told us we didn't have-
Well, no, I told you didn't have to substitute, but I'm going to make you write at least 2 lines. Write it with the plus c, and then you can just go straight to the 140. But put it with the plus c. Yeah, I know, but. Okay, and what did we? Oh, we wanted that when at 1.5 seconds, right? So we reached 1.5 or 3/2. 1.5. You can square that and multiply it by 5. I'm going to go with 3/2. Okay, so s of 3/2 is negative 5, 3/2 squared. What's the rest of it? Plus 15 times 3/2 plus 140. So it'll be negative 45 over 4. This will be 45 over 2, which is 90 over 4. And this will be 140 times 4, which is 560 over 4. 560 and 90 is 650, so it's 605. Would be what, 151 1/4 meters. Or you did it with the 1.5 and worked it out. 151.25 meters. Okay, is that, what did we do? C? That was C. Wow, that's a lot for C. D, velocity when it's 50 meters above the ground. Okay, so what do we have to work out?
Well, what S of T would
Well, yeah, what's T when S of T? So when S of, what is T? When S of T is 50. Okay, so what do we got? Negative 5t squared plus 15t plus 140 is equal to 50. Solve that. Minus. Okay. We wanted the velocity. Okay, so v of 6 is the velocity of the object. It's 50 meters above the ground. It's 50 meters above the ground. Okay, so we had to figure out the time when the displacement was 50 and the time was 6 or negative 3 seconds, so we're going with 6 seconds. And velocity was negative 45, and there we go. The velocity of the object as it hits the ground. So as it hits the ground, what's going on? So we need to find
S of t is equal to 0.
we need to find t when s of t is equal to 0, right? Okay. So we need t. All right, so what was s of t? Well, there it is there. Negative 5t squared plus 15t plus 140 is 0. So we're going to solve that. T squared minus 3t minus, what, 28? Okay, so 7 seconds, and we want velocity. So when it hits the ground, the object's velocity okay, and make sure you have the appropriate signs on the right, positives, negatives, objects being thrown up into the air. So I think, yeah, it's a good idea, anything with word problem, if you just write it out, you know, when this happens, this is what's going on.